All right. Okay, so let's go ahead and get started. What we're going to be doing this unit is talking about financial math. What we want to do is try and understand the math behind a lot of the, formulas and things that are important to our personal finances. Okay, so stuff that you'll encounter, right? So things that are really abstract or deal with like just businesses or stuff like that. We won't get into that. Okay. What we're going to do in this unit is focus on things like, how does interest work? We'll look at, saving money, loaning money. We're going to look at things like taxes and credit cards and mortgages and things like that. Okay. And the first unit that we have is going to be on percents, because that's from a mathematical point of view. Percents are the thing that underpins all of it, right? Taxes are all based on percents. Interest is all based on percents, right? Credit cards, everything. Okay, so this is kind of the underpinning idea behind everything that we do going forward, and we want to make sure that we have a really good foundation here. So this is probably going to be a lot of, especially this first unit, is going to be feel like review, and that's good. But you want to make sure that it's sort of fresh in your mind when we move forward for some of the more difficult stuff. All right, so here's our first thing. Percents. Percent is really a shorthand for a fraction. Okay, you can always think of the percent symbol as just meaning divided by 100. Okay, and so something like 15% is 15 over 100. Okay. And this is going to be, I think, very helpful from a mathematical point of view, because if somebody writes, 15% and somebody else writes the decimal 0.15, right? These are equal. These are the same number. So we don't have to, worry about, is there a difference? Is one preferred? I can't read one of them. So, you can just kind of freely go back and forth. Okay, and that's what we're going to do. So let's look at conversions. So if I want to convert, what we're going to do, since a percent is really just a fraction, we just sort of review how to go back and forth between, fractions and decimals. Okay. So if I want to convert a percent to a decimal, what we can do is just do the division, right? If I have something like 15%, that is shorthand for the fraction 15 over 100. So we just take 15 and divide it by 100. Okay. And I get 0.15. And the nice thing about dividing by 100 is it's just moving the decimal place. Okay. You can feel free to use your calculator also, right? I can 15 and say, okay, divide it by 100. Okay. And it just moves the decimal over and I get 0.15. Okay. So dividing by 100 moves the decimal place left. So if I want to go from a percent to a decimal, okay, we move left. Okay, if I want to go from a decimal to a percent, here we move right. Okay. So if I want to convert the following to decimals, suppose I have 32%, 158%, and 0.4%. Okay. This is just 32 over 100, so I move the decimal place left 2 places, 1, 2. That gives me a 0.32. Okay. This is 158 over 100. Again, I just move the decimal place left 2 places, 1, 2, so I get 1.58. Okay. 0.4, right? Percent means divided by 100. So if I want to convert to a decimal, I just move left 2 places. So left the first place will give me a 0 in front, and left the second place will give me 2 zeros in front. So 0.004. Okay. Going the other way, converting the following to percents. To convert to a percent, I want it to be a fraction over 100, so I'm just going to move. I'm going to do the opposite. I'm going to move the decimal right 2 places. So if I take 0.25, I move the decimal right 2 places, and I get 25%. Okay. 1.41, I move the decimal place right 2 places, and I get 141. And 0.0007, if I move the decimal place right 2 places, I get 0.07%. Okay. Now, some of these percents are smaller than 1, right? That's okay. 0.07% is, kind of a tiny number, but it exists. Okay. Percents can be bigger than 100%. That's fine. Percent, remember, is just a fraction over 100. There's no rule about fractions that says that they have to be between 0 and 1, right? We can have improper fractions, okay? In some contexts, we think of percents as a portion of a whole, right? So like if I'm splitting up a pizza and I say, okay, I'm going to give you 1 slice of this pizza, what percent of the pizza is it, right? Then that should be something that is a proper fraction, right? Or something between, 0 and 100%. But a lot of things that we work with, that doesn't have to be the case, right? And when we work with percents, oftentimes it can be more than 100%, and that's okay, right? There's nothing about percents that says that they have to max out at 100. Okay. All right, so let's look at computing with percents. The biggest problem that I think most people run into with percents, especially with computing with percents, is knowing which operation to do, right? Am I multiplying? Am I dividing? When do I do which one? Okay. So what we want to do is just sort of review how to go through that. And what I want to do is show you a framework for how to set up, a problem. Okay. So the key is going to be that when we say percent of, that means multiply. Okay. So if I take, like, to give you an analogy, if I say I have 4 of something, right, that means I have 4 copies of that thing, right? So, if you could think of, I have 4 identical copies, right? And that's kind of like what multiplication is, right? If I have 4 identical copies of 5, okay, then that's like 4 times 5 to see how much stuff I have. Okay. What we need to be very careful about is percents are fractions. And when I multiply fractions, I have to deal with the numerator and the denominator. Okay. And that can be kind of tricky. So a good way to avoid having any problem with percents is to typically just always convert it to a decimal before we do any math. Okay. And specifically multiplication and division. Adding percents works just fine, right? Subtracting percents, you don't have to worry about. But if you're going to do any multiplication or division, if you just convert to a decimal first, then you don't have to worry about it. Okay, so let's look at how we can go through an example here. So suppose my problem says, what is 40% of 65? The way that I'm going to go through this is I'm going to translate this sentence into math symbols. Okay, so what is an unknown? So I just put an unknown variable here, x. Okay. The math notation for is, right? If something is something, it's equal to that thing. Okay. 40% I write as a decimal, right? So I convert to a decimal, move left 2 places, so I get 0.4. Okay. Percent of means multiply. Okay. So when I have decimal numbers, I like to put them in parentheses for multiplying, because if I put like a dot, that can get confused if I'm sloppy, and it might look like a decimal point, okay? And if I put like a little x or something like that, well, that gets confusing because I already have an x in my problem, okay? And then I have my number 65. So then I just have a math equation, and I can see, okay, percent of means multiply. So I have 0.4 times 65, okay? Or I can just look at this as an algebra equation, and I can solve it, right? And I can say, okay, my unknown is 0.4 times 65. I get out my calculator, and I just type that in. Okay, there's no bonus points for doing mental math. So, you get your 26, and you're very confident that that's the answer. So 40% of 65 is 26. Okay. So what is 7% of 51? I do the same thing. I convert it. What is my unknown is 7%. Percent of is multiply. So I'm just going to take 0.07 times 51. And I get 3.57. Okay. Now, you might look at this and be like, well, I just know it's multiply. Can I just do that instead of, converting over? Okay. Yeah, if you see percent of and you just want to multiply them straight away and not write out a math sentence, that's fine. What I'm trying to do, though, is give you a structure so that if you have a confusing problem, right, you know how to set it up in a way that will allow you to unconfuse it, right? Okay. So here's a little table of the, English and math translation that we just did. Okay. And again, I think that it's very helpful to have, a way to take something complicated and sort of break it down into pieces. Okay. That's a really useful skill, especially in a math class, because, people get confused, right? It's very easy to get confused. Okay. So, again, taking an example here where I want to convert this into a math sentence. What is, so I have my unknown x, okay, 38% I write as a decimal 0.38. Percent of means multiply, and so I'm taking percentage of a number, so 0.38 times 61. Okay, and we get 23.18. All right, so now I have some examples where maybe things get mixed up a little bit. What if I say 54 is what percentage of 60? Okay, now it can get confusing, like, wait a minute, that's not saying percent of, right? It's changed a little bit here, so we have to be careful. But if I do the translation, it becomes very clear how to solve this, right? So if I translate this over, right, I just have the number 54. Is equals, my what is my unknown, so I put an X. Okay. And then I want percent of means multiply, so times, and then I have my number 60. So here I can see 54 equals x times 60 as an algebra equation that's very easy to solve, right? I say, oh, okay, I'm going to divide both sides by 60. That's how I solve this, okay? So if I take 54 divided by 60, I get 0.9, okay? So my unknown percentage is 0.9, right? So my answer is 0.9, or 90%. Okay. Okay, so again, that idea of translating, it creates an extra line of writing, but then it becomes very clear how to, what operation do I use, right? In this case, I was actually dividing the numbers, and it helps me know like which way to divide, right? Because again, percents don't always have to be a number between 0 and 1, so it's not always the bigger number on the bottom. Okay, so 32 is what percentage of 20? So again, I'm going to translate that over. 32, this is my equals, what percent? So I put my X here, and it's a percent of 20, so times 20. Okay, so then if I want to solve, we divide. Okay, so I'm going to take 32 divided by 20, and I get 1.6. Okay, Or if I convert that back to a percent, because it said what percent, I want to write my answer as a percent, I move the decimal back to the right to convert to a percentage. So we get 160% as our answer. All right. Any questions so far? Okay, so what I want you to do is try this one. Try example 8 without me, and let's see what we get, and then I'll go through it. So I'm going to give you like a minute or two to try it out. All right, so let's go ahead and try this now. Suppose the rent on an apartment is $900 1 year, and the rent goes up by 5%. Find the new rent amount, right? So the rent increased by 5%, so I want to know how much it went up. So let's say, what I want to know is, what is 5% of 900, right? That's kind of like the first part of my question. Okay, so we say, okay, well, I know how to do that, right? X equals 0.05 times 900. That's the translation work that we just did a minute ago. You say, okay, well, that's a very straightforward multiply. So 0.05 times 900 is 45. Okay. All right. Since 900 was in dollars, right, this is $45. So that means the rent went up by $45. So when it says find the new rent amount, I start with $900, and it went up by $45. So my new rent amount is $945. Okay, so we had a two-part question there. Okay, so we're going to build on that idea a little bit. So let's talk about percentage increase and percentage decrease. Okay, so we're going to use the same example, right? Suppose the rent went from $900 up to $999. What was the percentage increase? So it's kind of like looking at the same example we did, but flipping it backwards. Instead of saying, I know the percent increase, what is the dollar increase? This is saying, I know the dollar increase, what is the percent increase? Okay. So, I've already sort of structured how to do this, so we'll just kind of go through it really quickly. Okay. The steps when we want to find a percent increase is to first find what is the actual increase. Okay. So we want to consider how much of the increase there was, right? And that's going to be the difference. So going from 900 to 999, if I subtract, I get a $99 increase. Okay. So this is the amount of increase. Okay. Since the amount of increase is $99, if I want to find the percentage increase, what I need to do is answer the question, 99 is what percent of 900, right? So I have this $99 increase. Since I want a percent increase from 900, I want to know what percent that is of 900. So you can see how we're building up the process of how to solve this by sort of just talking it out and then translating what we talked out into math equations. Okay, so I want to answer this question. 99 is what percent of 900? Okay, so again, I translate the 99 is equals, what is my unknown? Percent of means multiply. So 99 equals 900 times x. So I can see, okay, there I divide. So I have 99 over 900 equals x. When I divide, I get 0.11 or 11%. Okay. So going from 900 to 999 is an 11% increase. Okay. Now, if you wanted to just like write down and memorize a formula, right? If we were to look in a book and say, how do you find percentage increase? Okay, percent increase equals, you could say the ending amount minus the starting amount divided by the starting amount. Okay. Now, the reason that I don't like this is because when I look at this formula, it doesn't make sense to me. Like, I don't know why do we do that? Why do you divide by the start? Why not divide by the end? Why not divide by the middle? So, sometimes I find formulas don't really tell you the story of what's going on, but like when I went through this process, that sort of did, right? So why do we have ending minus starting amount? Well, that's the amount of increase. Why are we dividing by the starting amount? Well, I want to find a percentage of how much I had to begin with, and if I have a number is a percent of something, to solve for that percent, I end up dividing, right? So that's sort of where that comes from. Okay. Now, we're not going to work with this so frequently that you have to like memorize a formula or anything. Okay. What I really wanted to do was sort of have this breakdown for you. I think it's more useful to be able to break down a situation you don't know and figure out what to do than it is to remember a formula. Okay. So let's do some examples where we use that. The population of Chicago was 282. That shouldn't be Chicago, that should be the US. The population of the US was 282.2 million in 2000 and 331 million in 2020. Find the percentage increase. I was going to start with a population of Chicago, but it turns out it didn't increase. It actually went down by a small amount over that period of time. I'm like, that's weird. I'll just use the US. Okay. So once again, what I want to do is pause for a second and let you try this one out, see if you can solve it, and then we'll go through it together. All right, let's go ahead and go through this one now. So we have the population of the US. We're starting with 282.2 million. And we're ending with 331 million. Okay. You can just think of million as being your units. You don't actually have to write the extra 6 zeros after our numbers here. Okay. So what we can do is first find the increase. And that's just the difference, 331 minus 282.2. Okay. So when I subtract, I get 48.8, right? Where my units are millions. Okay. And then we want to say, okay, 48.8 is what percent of 282.2 million? Okay. So 48.8 equals X times 282.2. Divide. So we get 48.8 divided by 282.2 equals X. Okay. And when I divide those, I get 0.1729270021. It doesn't come out to like a nice, neat terminating, decimal, right, in short order. So I say, okay, first I want to convert this to a percent, and then I probably want to round this a little bit. Okay. So we could say, okay, maybe if I round to a couple decimal places, if I move over to, I'll have 17, maybe 0.29, and I can write that as a percent. Some of you might have rounded to 17.3%. Maybe you just wrote 17%. 17% feels like it's maybe rounding a little bit too far. I like to, as a general rule, think how much rounding seems reasonable, and then go at least at one decimal more than that, right? So. Okay, so over the 2 decades, we had a 17.29% increase. Okay, so let's look at example 10. Example 10 is going to be very similar, except that our ending amount is lower than our starting amount. So instead of a percentage increase here, we're going to find a percent decrease. Okay. So the amount of decrease okay, if I take 28,000 minus 23,800, okay, I get 4,200. And then I say, okay, 4,200 is what percent of 28,000? So to solve this, I'm going to divide by 28,000. Okay. And so I get x is 0.15 or 15%. So here we have a 15% decrease. Okay, suppose instead of doing this by writing out all of these words, I just used the formula. I said, okay, if I want to find a percentage increase or decrease, okay, I say, the percent is going to be the ending amount minus the starting amount divided by the starting amount. Right, that was the formula I wrote down. So I plug in my numbers. So we have 23,800 minus 28,000 divided by 28,000. And I'm going to show you this on my calculator. Okay. In order to do that all at once, when I write this numerator, if I just type this in my calculator is going to do division first. I say, no, I want the subtraction first, so I have to make sure I put that in parentheses. Okay. So we have 23,800 minus 28,000. Oops. Okay. Divided by 28,000. Okay. And my calculator gives me a negative because when I use this formula, right, we didn't really, where is it? Here it is. We didn't really distinguish, right? We sort of wrote this formula for a percentage increase, and we didn't distinguish between a percent increase and decrease. Okay. And so a negative just indicates that you have a decrease instead of an increase. But I still get the right number. I still get that 0.15. Okay. So here we get negative 0.15. So I have a negative increase, which is a decrease. Okay, so it's just another way to kind of, go about the same thing. All right, any questions? Okay, well, the good news is things kind of ramp up pretty quickly, but I think these first few sections aren't too bad. What I'm going to do is spread them out a little bit, though. So what we're going to do, our first week has these 4 sections. We're just going to go through 1 section per day. So today we went through percents. Tomorrow we'll go through simple interest, and then we'll move on to compound interest and effective rates. Yeah. So what I'm going to do is I'll post the recording up today. It takes like a few minutes to process and then upload and things like that. So I should have it later on this morning, but early afternoon at the very latest. So yeah, every time we do a recording like this, I'll always post it up